Hello everyone and welcome back to the Proactive Learning YouTube channel. Today we're going to go through question 15 from the 2020 Paper 1 Pure Maths paper from Edexcel A-Level Maths. So let's see what the question is about. So we're told the curve C has the following equation: x squared tan y, which is equal to 9. We're also given an interval for what y could be in, and we're asked to show that the following derivative is equal to this expression. Now, something that should come to our attention straight away is that we have not only a variable x, but we also have a variable y in our equation. So in this case, we know that we have to use some sort of implicit differentiation. So let's go ahead and give this a try. So for part A, we have x squared tan y, and that is equal to 9. Now here, we know we have to use the product rule because we have an x squared and a tan y that are multiplying together. So let's let u equal x squared and let's let v equal tan y. From here, the derivative of u is equal to 2x. The derivative of v here, we need to be careful, is sec squared y, but we also need to add a dy by dx to it because that's implicit differentiation. From here, the product rule means we have to multiply the derivative of one with the normal form of the other. So in other words, our left-hand side would look like the following. We have x squared multiplied by sec squared y dy by dx. And then we're going to add 2x multiplied by tan y. And then the derivative of 9 is equal to 0 because the derivative of any constant is equal to 0. Now from here, something that we need to spot as well is the derivative the question wants us to show. It doesn't have any y variables, does it? It only has x variables in it. But in our answer so far, we've got sec squared y and tan y. So how do we either get rid of this or write it in terms of x? Now, a nice trick that we can use is we know what x squared tan y is equal to, don't we? It's equal to 9. Now, could we do anything or rearrange anything to find out what tan of y is equal to? We could, right? We could just divide both sides by x squared. So we have 9 over x squared, which is equal to tan of y. So in other words, we found out how we can write tan y in terms of x. Amazing stuff. But what about this sec squared y? Have we learnt any trig identities that let us write this, maybe in terms of tan of y, so that we can write it in terms of x? And there isn't an identity. So 1 plus by tan squared y, that's equal to sec squared y, isn't it? Now we know what tan squared y is. It's just 9 over x squared squared. Then we have a 1 plus there, and that is equal to sec squared y. So let's just simplify that. So in this case, sec squared y is equal to 1 plus 81 over x to the 4. So now we've got two different expressions that we can sub in. So let's do that. So we have x squared. Now instead of sec squared y, we'll write 1 plus 81 over x to the 4, dy by dx. And then we're going to add 2x. But then instead of tan y, we'll write 9 over x squared. And that is all equal to 0. So from here, what we want to do now is rearrange so that we can get dy by dx as the subject of our equation. So to do that, let's move 2x multiplied by 9 over x squared to the right-hand side. So then we would have x squared, 1 plus 81 over x to the 4, dy by dx. And all of that is equal to, in this case, we can multiply them and move it to the other side. We would get negative 18x over x squared. Now here, we've got an x at the top and x at the bottom, so we can just simplify it by removing the x on the top and changing the denominator to just x. From here, what we can do now is we can write this coefficient of our derivative as a single fraction. So we can write x squared, but now inside the brackets, we can write it as x to the 4 plus 81 over x to the 4, dy by dx. And all of that is equal to negative 18 over x. Now here, we can spot that we have a x squared in our numerator and x to the 4 in our denominator. So we can rewrite this as x to the 4 plus 81 over x squared dy by dx. And all of that is equal to negative 18 over x. From here, the last step to get our derivative is to just divide both sides by this expression here. So dy by dx is equal to negative 18 over x divided by x to the 4 plus 81 over x squared. Now from here, simple fraction division. So we have negative 18 over x. Now we can write it as multiplied by x squared over x to the 4 plus 81. And that is equal to negative 18x squared over x bracket x to the 4 plus 81. Now the last step that we can do here to simplify is we have an x squared on the top and an x on the bottom. So we can simplify it to negative 18x over x to the 4 plus 81. So that's our answer for the derivative. So let's see if that matches what the question wants us to show. So if we look back at the question wants us to show this form. So negative 18x over x to the 4 plus 81, and that matches with our answer. So that's part A all done. But now let's have a look at what part B asks us to do. So part B is saying, prove that C has a point of inflection at the following x value. Now something that we know is the point of inflection is where our second derivative, so d squared y by dx squared, is equal to 0, and where for our particular x value, the left and the right hand side have a different sign. So one is positive and one is negative. So to see what possible value could be a point of inflection, we first need to find out what x value lets our second derivative equal 0. Now we already know what our first derivative is. So we know dy by dx is equal to negative 18x over x to the 4 plus 81. But now here we need to use the quotient rule. So if we let the denominator equal v and let the numerator equal u and find the derivatives for each. So 4, or in this case, x to the 4 plus 81, its derivative is 4x to the power 3. The derivative of u here is negative 18. So as a result, our second derivative, or our second order derivative, d squared y by dx squared, is equal to x to the 4 plus 81 multiplied by negative 18, and then we will subtract 4x to the 3, which will be multiplied with negative 18x, and all of that is over x to the 4 plus 81 squared. Now here we can simplify our numerator a bit, can't we? So we have a negative 18x to the 4 and we have a negative 1458, and then we have a positive 72x to the 4, and all of that is over the same denominator. So we have x to the 4 plus 81 squared. So now here, if we simplify our numerator, what we get is 54x to the 4 minus 1458 over x to the 4 plus 81 all squared. Now the key thing that we need to understand here is, how can we show what values x can be for this entire expression to equal 0? Now whenever we have some sort of fraction that has algebra in it, the way that that can equal 0 is if our numerator equals 0. So in other words, we might have a possible point of inflection when our numerator is equal to 0. So when 54x to the 4 minus 1458 equals 0, we might have a point of inflection. So let's find out what possible x values there may be. So in this case, let's rearrange. So we have 54x to the 4 is equal to 1458. So x to the 4 is equal to 27. And from here, x is equal to the fourth root of 27. So this is quite promising, because if we look back at the question, we have now this fourth root of 27. But the only thing that we need to show now is there is some sort of sign change. So the key thing that we need to understand here is when x is less than the fourth root of 27, Our second derivative, so our d squared y by dx squared, our second order derivative is less than 0. We can infer that from our expression here, because our denominator is always positive, because it's a square, but then our numerator is going to be negative. On the other hand, when our x value is greater than the fourth root of 27, our second order derivative is greater than 0. And this is exactly the sign change that we want to show. It goes from negative to positive when it goes by this point of inflection where x is equal to the fourth root of 27. So that answers part B. Hopefully that answered some questions you guys had about sort of manipulating the algebra, going about answering the question. If there are any other questions you guys have, feel free to let me know in the comments below. So please like, comment and subscribe. That'll be it for today's video. See ya.